Hello students! Today's topic is about the process of determining the specific gravity of fine aggregates at saturated surface dry condition or SSD. Specific gravity of aggregate is the ratio of the mass of the unit volume of aggregate to the mass of the same volume of water. Saturated surface dry condition or SSD is the condition where the aggregates pore are filled with water but the surface is dry. The concept of determining the specific gravity of fine aggregate is similar to the coarse aggregate, but there are some differences between the coarse aggregate and fine aggregate. Fine aggregate can hold water not only in pore space of a particle but also in spaces in between particles. Turning the fine aggregates into SSD cannot be done by simply drying the surface of particles using dry cloth. Drying the surface of particles can only be done by exposing it to a moving warm air. Cone test method is used to determine if the sand attained the SSD condition. We also use the Chapman's plus in determining the specific gravity of fine aggregate. Other than specific gravity of fine aggregate at SSD condition, we can also determine the absorption of the fine aggregate in this test. Absorption is the capacity of the aggregate to absorb water into its permeable pores. Specific gravity of aggregate can be used in designing concrete and adjusting its weight, while absorption value is used to adjust the proportioning of material in concrete mix. The objective of this activity is to determine the specific gravity and water absorption of fine aggregate. For this activity, these are the following required equipments. To start the testing, first, soak the fine aggregates in water for 24 hours. Remove the water with care to avoid loss of fines. Place the aggregate on an unabsorbent flat surface and expose the aggregate to a warm moving air to dry. Stir the sample frequently to ensure homogeneous drying. Perform the cone test to check if the sample is at SSD condition. To perform the cone test, first, hold the cone on a smooth, non-absorbent surface. Fill the cone with fine aggregate into overflow. Lightly tamp the sample 25 times with the tamper over the entire area. Remove the loose sand from the base, then lift the cone vertically. If the shape of the sand is intact and does not slump, the sample is not yet at SSD condition. Repeat the drying process, then perform the cone test again later. If the aggregate slumps slightly, it means that the sample has reached the SSD condition, then can proceed to the specific gravity test. Weigh approximately 500 grams of saturated surface dry aggregate and record it as WS. Weigh the Chapman plus and record it as WF. Pour water into the plus to about 50% capacity. Pour the sample into the plus, then add water to about 90% capacity. Roll or agitate the plus to eliminate air bubbles trapped in sand. Immerse the plus in the water bath at 20 degrees Celsius for 3 hours. Fill the plus with water to its calibrated capacity. Make sure that the lower meniscus of water is level at the calibrated capacity. Weigh the plus with water and sample and record it as WT. You can now calculate the specific gravity of fine aggregate at SSD condition by using this equation. For the determination of absorption, first, weigh the pan and record it as WP. Pour out the sample into the pan. Make sure all the particles are washed into the pan. Dry the sample in the oven at 105 degrees Celsius for 24 hours. Weigh the oven-dried sample and record it as WD. You can now calculate the percent absorption of aggregate by using this equation.
24 hours later. Later. Much later. Much later. next day.
That's it. Hope you like the video, subscribe, and see you guys next time. Bye!